Hello everyone, welcome back to SMonk videos of CM1. In this video, we are going to discuss how to find present value and accumulated value of the cash flows. In the previous videos, we saw how to use different frequency of interest rates. We saw what is nominal and effective rate of interest. We saw what is nominal and effective rate of discount. We saw what is force of interest and how to deal with force of interest, which is a function of time. So now in this chapter, we have to see what may be the different modes of frequency of cash flows. When I use the word cash flow, it means just a transaction. It may be cash coming in or it may be cash going out. So it may be your income or expenses. So the cash coming in is referred to as cash inflow and the cash going out is referred to as cash outflow. So that those are income and expenses. So you have to learn instead of having just a single amount, how do we deal with the cash flows when we have multiple payments? So there is a cash flow. That means there is a set of multiple payments, and we have to deal with finding present values of these payments and different interest scenarios. So when I say cash flow can be in two different types. One can be discrete cash flow. That means cash flow occurring at specific time intervals, and the other kind can be continuous cash flow. That means cash flow occurring every day. So let's think of a business like a Paytm or Amazon or Flipkart. You can estimate or you can understand the number of frequency, the number of cash flows, the number of transactions that must be happening every second. So Paytm is basically earning some money, or Flipkart is earning some money, or Amazon is earning some money every point of time, every second of time, maybe more than one transaction every second. So 24 hours a day, 365 days a year, they are earning money. So there is the money that is coming in is called as continuous. So you are earning money at every point of time. Now think of a cash income of someone like us who work on salaries. So the money comes in on the first of every month, but goes out on each day. So you spend some money each day. So your expenses may be continuous, but income is discrete. Discrete means it occurs only on specific intervals, like on the first of every month or the second of every month, or maybe once in a year, or twice in a year, or 3 times a year, or once in 2 years, once in 3 years, something like that. So we have to first understand how to deal with discrete cash flows, which occurs only on specific dates using different rate of interest, and then we have to move on to understand how to deal with continuous cash flows. We have to learn how to find present values as well as accumulated values at some specific date of both of this type of cash flows. So let us first start with the discrete cash flow cases. So let us just understand with an example, which is the best way to understand. So let's say there is a cash flow rupees 100 at time 1, rupees 200 at time 4, and rupees 500 at time 7. Now this is a cash flow. Do not think of whether it is income or outgo. Just think that some payments or some cash flow will occur on the specific dates. Let's assume that these are your incomes. So you'll be earning let's say 100 rupees at time 1, 200 at time 4, and 500 rupees at time 7. So you're supposed to receive 3 income because of some transaction or because of some investment. Now what is the present value of this 3 incomes at time 0? Using find present value at time 0 using number 1, when interest rate is given as, let's say, 10%, or when discount rate is given as, let's say, 10%, or when the force of interest is given as 10%, or when I4 is given as 10%, when D2 is given as 10%, or when the force of interest is given as a function of time, which may be, let's say, 0.09 plus 0.001 t square for t greater than 0. So this is one cash flow. Your interest rate can be of any other type. You have to learn how to find present value of this cash flow using any of these interest rates. So first of all, the present value should be like this. Your 100 rupees is due after 1 year from today. You have to pay someone 100 rupees, you have to receive 100 rupees after 1 year. So present value of 100 rupees at time 0 is 100 into V. We learned in the previous video that V is used to denote a discount factor of 1 year. which can be evaluated using any of this function, but writing v means that we have to discount 100 rupees by 1 year irrespective of whatever the rate of interest is or whatever the discount it is, whatever the forced interest is. It just means that you have to discount 100 rupees for 1 year. Now second is 200, which is due 4 years from now. So we write 200 v raised to 4 and then 500 v raised to 7. So in all these cases, this should be your first equation, that 100 rupees have to discount for 1 year, 200 for 4 years, and then 500 for 7 years. Now to solve this equation, you have to use this information. So first case we have interest rate given as 10%. So I can write now this equation as 100 into 1 plus 0.1 raised to minus 1 plus 200 into 1 plus 0.1 raised to minus 4 plus 500 into 1 plus 0.1 raised to minus 7. I have just used the relation that v is equal to 1 plus I raised to minus 1. This is a relation we studied in the previous chapter, and I have just used this relation to write this equation. Now I need to find its value. So let's check what is the value using the calculators. So your answer comes out to be 484.0908411. That is my answer without any kind of rounding off. That's the exact answer that I got. So when interest rate is 10%, the present value of this cash flow, the actual amount being paid is 100 plus 200, that is 300 plus 500, 800 rupees. But this 800 rupees is being paid at several time intervals which are not at time 0, which are being paid sometime far away from time 0. So when you find its present value, the present value of this 800 rupees that is total being paid is 484 rupees. So 500 being the largest amount is being discounted for the highest time period. So the value of 500 rupees decreases drastically. 200 rupees value will also decrease. 100 rupees value does not decrease too much, but it decreases by 10%, and 10% interest is very high. So it is reasonable to have such a small value for a present value of 800 rupees. So that is how we have to deal with the cash flows. So you just need to individually discount all of them to time 0 and add them up. There is no other signs involved. Discount each and every cash flow individually to time 0 and add them up. So now for the second case, when d is 10%, in this equation I can write present value is equal to 100 into 1 minus, you can use the relation v is equal to 1 minus d. So 0.9 raised to 1 plus 200, 0.9 raised to 4 plus 500 into 0.9 raised to 7. So this is my equation. 0.9 was because it is 0.1 minus 0.1 is 0.9. So now let's see what is the answer. So answer that comes is 460.36845. Now this answer is smaller than the previous answer, 484. Now why did that happen? The interest rate was 10% in both the cases. Now here the interest rate is 10% at the start of the year, so that is discounted basically. Now a 10% discount rate is basically equivalent to something like 11% as the interest rate. If you convert your D to I, you may get your answer as something 11 point something percent probably. So here if you want to use the same equation, you have to convert D 10% to I something percent, whatever percent it is, by the relation I is equal to D upon 1 minus D, and whatever percentage you get, 11 plus 11 point something percentage, if you use it here, yeah, this answer will definitely reduce. So this 484 is at I equal to 10%. When you increase the interest rate, the present values tend to reduce. So if you increase the interest rate, the values are discounted even more. So more discounting means that present value decreases more. So there is an inverse relation of interest rates and present values. So when I said discount 10%, it means interest rate is something more than 10%. So hence the present value is even lower than the previous case. Now the third case is force of interest 10%. So present value is, we have to use the relation that V is equal to e raised to minus delta. We saw all these things in the previous videos. So 100 into e raised to minus 0.1 plus 100 into e raised to minus 0.1 into 4 plus 500, that is, sorry, this is 200, then 500 into e raised to minus 0.1 into 7. Let's see what is the answer. 100 into e raised to minus 0.1 plus 200 into e raised to minus 0.1 into 4 plus 500 into minus e raised to minus 0.1 into 7. So answer that comes out is 472.84040029. This is the answer that I got when delta was 10%. So these are my answers using I, D and delta. Now similarly we have to find answer using I4. The question says that what is the present value when I4 is 0.1. So now I have two options here. Either I use I4 as it is or I convert it into I first. So I can find corresponding I using this I4 and then use this relationship, this equation. Just replace your I from 10% to whatever corresponding I you get for this I4 equal to 10% and use it in this equation. Or you can do is use I4 directly. So I'll prefer using I4 directly because that will reduce my time and efforts. So 100 rupees. Now when I say I4 is 10%, it means that annual rate of return payable quarterly. Annual rate of return payable quarterly is 10%. So 10% per annum payable quarterly is equivalent to saying that 2.5% per quarter is the effective rate of interest. So instead of writing everything in number of years, I can just convert everything in number of quarters. So I can discount 100 rupees by 1 plus I4 by 4, I4 by 4 being the quarterly rate for 4 quarters instead of 1 year. So raised to minus 4. Then 200 rupees I can discount 1 plus I4 by 4 raised to minus 4 into 4. So there are 16 quarters in 4 years. Instead of 4 years, I can use 16 quarters and the quarterly rate. Then the last part 500, 1 plus I4 by 4 raised to minus 4 into 7. So there being 28 quarters in 7 years. So in this equation of I4 by 4 is 2.5% and just put that and get the answers directly. I'll just write the final answer using I4 by 4 is equal to 2.5%. So answer comes out to be 475.758943. I have not done any rounding off here. This is my exact answer. If you convert from I4 to I and then if you round it off to let's say 4 decimal points or 5 decimal points and then you try to find out the answer, your answer will vary maybe in 3rd or 4th decimal point, but it should not vary more. So be very careful when you're converting from one to another. Do not round it off too much. If you round it off too much, the accuracy will be lost definitely. So this is how we solve for the first 4 cases. Now let us try for the 5th case. So the 5th case says that D2 is 10%. So that means nominal rate of discount per annum payable half yearly is 10%. That means the discount rate is 5% every half year. So now again, instead of converting your D2 to D and then using the same equation that we used for part 2, we can use D2 by 2 as 5% directly in prime equation. So the present value for the 5th case should be 100 into 1 minus D2 by 2 whole raised to 2. There are 2 half years in first year. Then 200 into 1 minus D2 by 2 whole raised to 2 into 4, denoting 8 half years in 4 years, plus 500 into 1 minus D2 by 2 whole raised to 7 into 2, denoting 14 half years in 7 years. And then I can use D2 by 2 as 5% and get my answer. Let's see what is the answer. 100 into 0.95 raised to 2 plus 100, 200 into 0.95 raised to 8 plus 500 into 0.95 raised to 14. And my answer comes out to be 466.77157558. So these are the answers using different rate of interest and discount. We used the first 5 cases where interest rate, discount rate, delta, I4, D4, all the 5 cases that we have studied in the previous videos are covered here. Now we have to deal with the case where a function of interest is given. So let's try that. So now here this 100 rupees have to discount for 1 year and the force of interest is given as function of time. So your present value should be 100 into e raised to minus 0 to 1 because I have to discount for 1 year only. 0.09 plus 0.001 t square dt plus 200 e raised to minus 0 to 4 because I have to discount for 4 years. 0 to 1 denotes discounting from time 1 to time 0. This is from time 4 to time 0 using the same equation, and then 500 e raised to minus 0 to 7, 0.09 plus 0.001 t square dt. Now there is a very important thing to note and learn over here. So in this equation, as you can see, we are doing integration 3 times, but every time the integral is exactly the same, just the number that I have to substitute keeps on varying every time. So instead of integrating for 3 times, what we can do is we can find the general expression for this integral. So I can say that let's find, I can use a term for this, general factor for a general form of Vt or V raised to t. So let's first assume that the upper limit is not known. Let's first assume that upper limit is not known, and let us find the general expression for an integral from 0 to t 0.09 plus 0.001 s square ds. Now I have replaced t by s because the upper limit contains t. Now we can integrate it once. So this is e raised to minus 0.09 s plus 0.001 into s cubed by 3 from 0 to t. So this becomes e raised to minus 0.09 t plus 0.0005 t cube. When you substitute 0, the whole term becomes 0. So this is my expression for this integral. Now when I want 1, I can just substitute 1 over here and I get my answer. When I want 4, I can substitute 4 over here and I get my answers. When I want 7, I can substitute 7 over here and I get my answers. So that is how simply we can derive we can solve this expression by integrating just once. And now I can write this is equivalent to 100 into e raised to minus 0.09 into 1 plus 0.0005 into 1 cube plus 200 e raised to minus 0.09 into 4 plus 0.005 into 4 cube. So this is 3 times 0 and then 5. So be very careful. Into 4 cube plus 500 e raised to minus 0.09 into 7 plus 0.0009 into 7 cube. So all the integral I just found with single expression, keeping the upper limit as t instead of the specific numbers. The integral should never ever change. It's the way we solve it just by the limits. So limits is something that is just to be substituted. So we can first keep t. When we keep t, this is called as the general expression. We can call it discount factor in general, which can be used for any kind of tree. So when it is v1, we can just substitute 1. When you want v4, we can just substitute 4. When you want v7, we can substitute 7. That is what we exactly did over here. So once you find an expression, use that to solve this simply in one shot, and then you get your answer. So let's see what the answer comes out to be. Be very careful to put 3 zeros, because sometimes it's very common that we miss 1 0 while putting things in the calculator and the answer comes wrong. So that is a very common error that we have seen. This should be 0.005. I'm sorry for that. So answer that we're getting is 450.815991. I hope that you also get the same answer, and in case there is a difference in the answer, just let me know so I'll cross check. So this is the answer that I got in the first try, and I hope that is correct. So this is it in dealing with the present values of the discrete cash flows. Using different rate of interest, you can deal with the different method of solving. Let us solve some more questions on this to understand things in little bit more detail, or just practice a few more questions on this right now. Let us now do some more sums on the present value of the distributed cash flows. So let's say that I have rupees 200 due at 9:10 and rupees 300 due at 9:15. The question says that the force of interest is 0.08 plus 0.001 t or 0.01 t for t between 0 to 5, 0.09 plus 0.05 t square for t between 5 and 10, and 0.1 for t greater than 10. This is the three different force of interest given to me, and I have to find present value of two cash flows, that is 200 rupees and 300 rupees. So very simply, we just have to discount both the cash flows manually, separately, and then add them both. So first, let us do for 300 rupees. So present value is 300 V ratio 15 plus 200 V ratio 10 actually. Then we have to find what is the value of 300 V ratio 15. So it should be 300 into. Now the force of interest that is given is three different force of interest. So we have to discount in three different ways or in three parts. So first of all, e raised to minus. First of all, to bring the value from time 50 to time 10. Now from 50 to 10, you know that the force of interest is constant. So we can simply do minus 0.1 into 5. We don't have to integrate it since it is a constant force of interest given after time 10. So 5 years we discount it using the constant force of interest. So this brings the value of 300 rupees from time 15 to time 10. Now we have to go from time 10 to time 5 first, because that's where again the interest rate will change. So e raised to minus integration from time 10 to time 5, 0.09 plus 0.05 t square dt, and then from minus 5 to 0, 0.08 plus 0.01 t dt. So you split the discount factors and multiply them. So first you get a value from time 15 to time 10, then 10 to 5, and then from 5 to 0. So wherever the force of interest change, you have to break the discount factor in such a way and multiply them, not add them or multiply them to each other. So this is how we get present of 300 rupees, and then we have to find present of 200 rupees. So this is 200. Now 200 is at time 10. So we have to discount from time 10 to time 0. So in that case, the interest rate which is applicable after time 10 will be useless. So we don't have to take into account this 10% anywhere. We will only discount from time 10 to 5 and then from 5 to 0. So first of all, let's do it from 10 to 5. Minus 10 to 5. 0.09 plus 0.05 t square dt into e raised to minus 0 to 5, 0.08 plus 0.01 e dt. So these are the same integrals that we are using here. So once you have integrated it here, you don't need to solve it again. You can just use the values as it is from the previous part of the question. So this is how it works. I won't solve it right now to save our time, but you have to solve it yourself. Write the equation first, see if you have understood why the equation is wrote like this, and then once you understand the logic behind it, then you solve it and check what the answer is. So answer is given on the screen. You can cross check the answer is exactly the same. So this is how we deal with the cash flows when the force of interest is there as a function of time and it changes with time. So even the function changes with time. So this is how we deal with it. So there are more questions in the practice sheet that is applied to you. Please follow that practice sheet and solve more questions based on this kind of questions. Now let us try accumulating the cash flows from one point to another. So let's see how accumulation works. So I'll write a question again and then we'll solve it using different ways. So again I'll just write the equations, and wherever possible I'll write the solutions also. And wherever it is not possible, I'll just write the equation and I will leave it for you to solve it. So to start with, let's say rupees 100 due at time 0, or whether I should use the word rather invested. Rupees 100 invested at time 0, rupees 300 invested at time 2, and rupees 500 invested at time 5. Find accumulated value at time 10 using number 1, interest rate 10%, number 2, discount rate 10%, number 3, force of interest 10%, number 4, I3 10%, and number 5, B6 10%. And for force of interest as a function of time, we will solve one question for this. So let us first understand for this kind of situations, if we have 3 cash flows and we want to accumulate all of them at time 10, how much money will we have in the account at time 10? So you are investing these 3 amounts basically, and you want to check what is the amount you will be having at the end of the given account. So accumulated value at time 10 is equal to the 100 rupees that is invested at time 0 will accumulate for full 10 years. So 1 plus I before ratio 10. Then you invest some other amount at time 2. So amount invested at time 2 till time 10 will accumulate only for 8 years. So 300 rupees into 1 plus I raised to 8. And then finally invest 500 rupees at time 5, which will accumulate only for 5 years. So from the point where it is invested till the point where it is redeemed or the disinvestment happens. So the first investment earns interest for 10 years, the second for 8 years, and the third for 5 years. So 10 into 5 accumulated accordingly. We just use the calculator and get the answers. So let me see what the answer is, and you solve it yourself and see what the answer is. And cross the data with my answer. So answer that I am getting is 1707.705889. I hope that's the correct answer. Let me cross check once. So yeah, that's the correct answer. So now this was accumulation using the interest rate. Now let us accumulate using the discount rate. So 100 into 1 minus d to the power minus 10. When you want to accumulate using discount rate, the accumulation factor is 1 minus d raised to minus 8. Then 300, 1 minus d raised to minus 8. Then 500, 1 minus d raised to minus 5. So using discount rate 10%, let's see what's the answer. 1 minus d is 0.9. So 0.9 raised to minus 10 into 100 plus 300 into 0.9 raised to minus 8 plus 500 into 0.9 raised to minus 5. So answer I'm getting is 18302.468783. That's how we accumulate using discount rate, and so on. The process goes on as it is for the other 3 aspects. So while I'm solving for me, you can solve it for yourself, and then just cross check the equations are matching if the answers are correct. So 100 e raised to delta into 10 is to be used when you're using discount, when using force of interest. 300 for 8 years, so delta into 8, and then for the 500 for 5 years, so e raised to delta into 5. Delta being 10%, let us see what's the answer. The answer is 1763.85. Then let's try it for I3 equal to 0.1. So one of the way that we discussed last time also, that you can convert I3 to I and use a similar equation. Just instead of in this I, instead of 10%, you can use the corresponding I that you can derive using I3. Otherwise, you can solve it using I3 itself. So solve it directly should be 100 into 1 plus
I3 by 3 raised to 3. When I do 1 plus I3 by 3 raised to 3, it becomes accumulation factor for 1 year. I have to find for 10 years, so I will do 10 plus 300 1 plus I3 by 3 whole raised to 3 into 8 plus 500 into 1 plus I3 by 3 whole raised to 3 into 5. This should give me the answer. The answer is 1744.108784. So I hope you're getting the same answers and understanding what I'm doing. Then if we use B6 is given as 10%. So 100 1 minus B6 by 6 raised to minus 6 becomes discount accumulation factor for 1 year using discount rate, and you have to do it for 10 years. Then add 300 1 minus B6 by 6 whole raised to minus 6 into 8. Then add 500 1 minus B6 by 6 whole raised to minus 6 into 5. B6 is given as 10%, so let's see what the answer is. The answer is 1774.148683. Let me cross check that is the answer right also. So that's what I'm getting. So these are the answers for accumulated values using the different rate of interest or discount or the cost of interest, IPDP, INT and delta. So now this is how it works for these simple cases. Now let us try to understand the similar case for cost of interest when it is given as a function of time. So let us look at this next question.
So now we will look at the ways to accumulate when the force of interest is given as a function of time. So let's consider a very simple example. Let's say invest rupees 200 at time 0 and rupees 300 at time 6. The force of interest is given as, let's say, 0.08 for t between 0 to 5 and 0.08 plus 0.01 t for t greater than 5, and we need to find accumulated value at time 10. Now how do you solve this kind of a question? That is the task. So 200 rupees we have to invest at time 0. From 0 to 5 it will earn interest based on this force of interest, and then from 5 to 10 it will earn interest on this force of interest. So your 200 rupees accumulated value will be, since the first 5 years it is constant, it can be directly 0.08 into 5 for the first 5 years. Now after that it becomes a function. So we have to integrate from time 5 to time 10, 0.08 plus 0.01 t dt. Now while making such kind of an integration, make sure that you use the exact time from which you have to accumulate from where till where. So sometimes some students make it 0 to 5. Now since this is a linear function, it will not make any difference. But when the function is not linear, in that case, instead of 5 to 10, if you write from 0 to 5, it's basically 5 is only. So if you write 0 to 5, the answer will come different if it is not a linear function. So right now, since it is linear, doesn't matter. But later on, be very careful. Whenever the function is not linear, you have to be very careful that the time should be exact from where till when you have to invest. So the suggestion would be that whether it is linear or non-linear, always write the exact time from which you have to accumulate, the point from which you have to accumulate till the time where you have to get the accumulated value. And that should not be any negative because here you're accumulating, so the value should be positive. And the second part, plus 300 e raised to, from time 6, since you're investing at time 6, from time 6 to time 10, we'll be using only this force of interest, 0.08 plus 0.01 t dt. So here the interest rate or the force of interest given from 0 to 5 will not be applicable because the investment itself happens at time 6. So any interest rate applicable before time 6 is basically useless in this kind of a question. For this, basically this cash flow, for any cash flow that occurs after time 5. So if there is any cash flow at time 8, time 9, time 10, anytime after time 5, I'll be using only this kind of an integration. So the first part will be useless right now in the second part of the equation. So now let us try to solve this. So let us first find the value of e raised to 5 to 10, 0.08 plus 0.01 t dt, which is e raised to 0.08 t plus 0.005 t square. It is t square by 2, so I just adjusted upon 2 with 0.01 coefficient, and the limits are from 5 to 10. So e raised to 0.08 into 10 plus 0.005 into 10 square minus 0.08 into 5 plus 0.005 into 5 square. Let's see what the answer is. So answer of this part is 2.1705 92127. Then let us solve for 6 to 10, 0.08 plus 0.01 t dt, which is e raised to 0.08 t plus 0.005 t square from 6 to 10. So you substitute 10 first, 0.08 into 10 plus 0.005 into 10 square minus 0.08 into 6 plus 0.005 into 6 square. Let's see what the answer is. The answer comes out to be 1.896480,879. So these are my two answers for the integral part of the equation. Now, with the substitute the values here, and you'll get your answers directly. 200 into e raised to 0.08 into 5 multiplied by 2.17059,217. So answer the first part is 647.6285887 plus the answer of second part is 300 into 1.896480,879, and the answer comes out to be 568.9442637. And the final answer is 1216.572852. This means if you invest this amount using this rate of interest which is applicable, this will be the amount in your account by the end of the 10th year. So this is how you deal with the accumulation part using force of interest as a function of time. So I hope that was simple. Now let us move on to the cash flows which are continuous. This was present values and accumulation of discrete cash flows. Discrete cash flows, as we discussed, are the cash flows which occur very rarely or at regular intervals, not every day. So I would not say rarely, that would be a wrong word, but using the word that it occurs at regular intervals with some time gap in between is the right definition of discrete. Now we have to deal with continuous cash flows, the cash flows which occur continuously throughout the year. That means the cash flow is occurring every minute or every second, or maybe more than once in a second. So let us see how to deal with that. First of all, let us understand how the cash flow looks like when it is continuous. So there is a term that we use to denote a continuous cash flow, which is called as payment stream. This is continuous cash flow. And we use the word or a notation rho. This is pronounced as rho t. So my cash flow here is a function of time. It may be constant also sometimes, it may be function of time also. We will use this notation everywhere, be it constant or be it a function of time. So let us first understand how to deal with cash flows which are constants but continuously payable. That means that the rate at which the payment is being made is continuously throughout the year. It is constant throughout the year, but it is being paid every day. And then we will deal with cash flows where the payments changes with the time. So as the time increases or as the time changes, the payments might increase or decrease. So let's say, for example, your rho t, which is the payment stream, is 100 per annum. Now what does it mean? So the rate at which the payment is being made is 100 per annum. Now let us try to understand this. When I say 100 per annum, it doesn't mean that the payment is being made every day. It is being made the amount that is being paid every day is rupees 100. That is not what it means. It means that the amount is being paid in such a way that the total value paid throughout the year will be 100. So if I say that I'm driving at the speed of 80 kilometers per hour, and if I drive for 5 minutes, it does not mean that I have covered full 80 kilometers. Only when I drive for 1 hour, it means that I will have covered 1 full kilometer. Here in the similar way, when I say the payment is being made at the rate of 100 per annum, if I make the payment only for half of a year, the total amount paid would actually be 50 rupees only. Only when I complete the whole full year, the total amount that will be paid or in the account will be 100. So if you want to find out total amount paid in say 10 years, it would be 100 into 10 simply because it is constant right now. The payment is not changing. Here we are not finding the accumulated value right now. We are first dealing with how to calculate the amount paid, the actual amount paid, ignoring the interest rates for the time being. So the payment is 1000. But what if I say that the payment is being made at the rate of 100 plus 20t, for t between, let's say, from 0 to 10. So now here my payment is a function of time. So here in the first year the payment is being made at the rate of, by the end of the first year the rate of payment is 1. At time 0 the rate of payment is 100. At time 1 the rate of payment is 100 plus 20. At time 2 the rate of payment is 100 plus 40. At time 3 the rate of payment is 100 plus 60. And it does not actually change only at the year end, it changes throughout the year. So maybe at time 0.5 the rate at which you are making the payment is 110. 100 plus 20 to 0.5. Maybe at time 1.5 the rate at which the payment is being made is 130. So the rate of payment is changing every single minute, every single second. The payment at the rate at which the payment is being made is increasing with time. So this is what the function is. Now if you want to find total amount paid in 10 years, how will you do it? So now here we have to add the payments over a continuous range. So we know that we can add the payments over a continuous range by integrating the function over the required range. So here we will integrate from 0 to 10, 100 plus 20t dt to get the total amount paid over this time period, which is 100t plus 20t square by 2, 0 to 10, which is 100 into 10 plus 20 into 10 square by 2, and this, when you put 0 it becomes 0. So this is 100 into 10, that is 1000. 100 square is 10 square is 100. 20 by 10 is 10. So 10 into 100 is again 1000. So total amount paid in 10 years is rupees 2000. Here we have not found the present value or the accumulated value. We were just trying to find out how to add up the amounts that is being paid, because the rate is changing. The amount that is being paid at every minute or every second or every moment is different. So this is how we calculate the total actual amount paid into the account. Now we want to find out when this amount earns interest, what may be the accumulated value or what may be the present value. So it's very simple. So first of all, let me write this thing in a standard format. If you want to find total amount paid between time A and B, you integrate from point A to point B the given payment stream with respect to time dt. This will give you the answer. Now if you want to find present value of amount paid between time A and B, what you will have to do is from A to B, the payment stream multiplied by the discount factor. If you multiply your payment stream by the discount factor, then you integrate, it will give you the present value. We will shortly justify how this is correct. So for the time being, let us just accept this as a definition or the basic formula that multiply payment stream by the discount factor and then integrate from whatever point you want to integrate. And then if you want to find accumulated value of amount paid between time A and B, it should be A to B rho t accumulation from time t to time B. We will again see how this is correct. For the time being, let us just write it as a formula. So this will give you accumulated value at time B. So if you want to find accumulated value at time n, it should be n. So payment can be from 2 to 5, but you may want to find accumulated value at time 15. So even if the payment is between 2 to 5 and you want to accumulate to time 15, this should be 2 to 5 and this should be t, 15. That is how it works. So this will give you the total amount, this will give you the present value, this will give you the accumulated value. Of course, we will be dealing with these two only. This was just for your understanding that why we integrate and how does it add up the values or how to deal with the functions when it is changing with time. So this and this are the two equations more important for us. Now let us understand the application or the understanding of these equations using an example. So if I say your payment stream is rho t is equal to e raised to 0.1 t for t between 0 to 5, and the question says that your payment stream the force of interest is 0.08 plus 0.01 t dt. Sorry, 0.1 t, and that this is also between 0 to 5, for example. So now, if you want to find present value at time 0, what should you do? And then if you want to find accumulated value at time, let's say 5 for the time being. So let us write the equations for both of them first and then we try solving it. So present value is integration from 0 to 5. The first integral will always be the time between which the payment is being made. Nothing else. It is mandatory and you can use it blindly everywhere, that the range of the first integral should be the time when the payment is being made. Then the payment stream 0.1 t. That's what we wrote for present value. So A to B was the payment time when the payment is being made. Then we wrote the payment stream, and now we have to multiply that by the discount factor. So here discount factor should be e raised to minus integration of 0.08 plus 0.01 s ds. Instead of t, I'm using s for a reason. Now we want to discount everything to time 0. But the payments are being made at time 5, time 4, time 4.5, time 4.7, time 4.8. So every payment is supposed to be discounted for a different time period. You cannot have a standard discount factor for all the payments. So let's say if I write 0 to 5 here, this would independently mean that this is a discount factor of 5 years. So this would independently mean that every payment is being discounted for 5 years. So payment which is made at time 5 comes to time 0, but payment which is being made at time 4 will go to -1. The payment which is being made to 3 at time 3 will go to -2. So if you write simply 0 to 5 over here also, every payment will go 5 years behind, because this becomes a standard constant discount factor of 5 years. But we need a more dynamic discount factor because there are different payments being made at different time period. So the payment which is being made at time 5 should get discount for 5 years only. But the payment which is being made at time 4, if this takes value 4, this should also take value from 4 to 0. Because you want them to be at 0 only. So discount factor should change. So when this t is 4, this should be from 4 to 0. So when this t is 3, this should be from 3 to 0. When this t is 3.5, this should be from 3.5 to 0. So to ensure that every payment is discounted only for the time it should be, to bring it to time 0, we should use the upper limit as t. So this makes sure that whatever time the payment is being made, it is being discounted for the same time period. So if the payment is at 4.7, it will be 4.7. If the payment is at time 4, it will be 4. If the payment is at time 3, it will be 3. So this is how you write the equation. So first you will solve this integral. When you start solving it, you'll solve this integral first. Then whatever answer it is, you'll add both the powers, and then you'll integrate this again. So first you need to integrate this, and then you need to integrate this after combining this and this factor together. So this is how the equation for present values work. Now how do you solve for accumulation? We want accumulation at time 5. So 0 to 5 e raised to 0.1 t. This remains same. There is no change in the payment stream and the limits. Now instead of discount factor, we have to use the accumulation factor. So if we again write 0 to 5 here, 0.08 plus 0.01 s ds, this would mean that this is an accumulation factor of 5 years, a constant accumulation factor of 5 years. So payment which is at time 0 will go to time 5, but the payment which is at time 1 will go to time 6. The payment which is at time 2 will go to time 7. Every payment will go 5 years ahead of its time. So, but we don't want to do that. We want to accumulate the payment at time 0 only for 5 years. Payment at time 1 only for 4 years. Payment at time 3 only for 2 years. Payment at time 4 only for 1 year. Payment at time 4.5 only for half a year. So payment should accumulate only for the time required so that it reaches time 5, not beyond that. So here this should not be 0. We know that we want to accumulate it to time 5, but then it should start from t. So when this t takes value 0, this is from accumulation from 0 to 5. When this t takes value 1, this becomes accumulation from 1 to 5. When this t takes value 1.5, this becomes from 1.5 to 5. So every payment will have a correspondingly different discount factor, which is suitable for it to bring that value to time 5, accumulate the value to time 5. That is how it works. So we have to be very sure about it. Whenever you want to discount, there should be one t in the discount factor for sure, and that should be in the upper limit. That is always the case when you discount. The t is always in the upper limit, and the lower limit is fixed because that is, you know, that you want to bring it to time 0. But from where? So there are many payments from where you have to bring to time 0. So from where should be a variable which should take any value from 0 to 5. And here you know that you want to accumulate to time 5. So where you want to accumulate is fixed. But from where? From which point you want to accumulate is a variable, because there are different points from which you have to accumulate to time 5. So lower limit should be t always. So there will be one t in the integral for sure. Whenever there is an integration and there is a payment stream, the discount factor or the accumulation factor should have one t in it. One of the limits, it should have one t. That should be a variable, and that variable should be in the lower limit whenever it is accumulating, and should be the upper limit whenever it is discounting. And be also sure that make sure that you put a negative sign and a positive sign when you write a discount factor and the accumulation factors. So this is how the equation looks like. So for the timing, just write the equation. We will use another question to understand this in much more detail. So for the timing, just write this equation, and let us move on to the next question. So now let us have a look at this question. So in this question, we have three different force of interest applicable for the same time period. So from 0 to 1, we have the first rate of interest, that is around 4%. From 1 to 5, we have 5% variable minus 1% constant. And for t greater than 5, we have 24% constant. And this is the payment stream. This is the rate at which the payment is being made between time 5 to time 10. So payment does not start from time 0. The payment here is started from time 5. And we need to find the present value at time 0. So I'll teach you how to write the integral again, and I will leave it to you to solve it yourself. So here the first we have to find, you have to write an integration. We need to find present value at time 0. So integration limits first of all should always be the range between which the payment is being made. Between which the payment is being made. And then you write the payment stream, 25 e raised to minus 0.02 t. So this is the first thing. Now after that, we need to discount it. So there there are three different rate of interest applicable from time between time 0 to 10. So we'll have to consider all of this. So always start from the highest one. So we saw in the previous example that there is always one t in the limits. There's always one t. So here when you have three different integrations which are supposed to be involved, we will always use t for the highest one. So from time t, let us first write from time t to time 5. 0.24 ds. So just this much of the integral ensures that the payment which is being made from time 5 to time 10 is all of them discounted to time 5. So this will bring from time 10 to 5, 9 to 5, 8 to 5, 7 to 5, 6.5 to 5, 6 to 5. Every payment is now discounted to time 5. Now we have to bring this payment down from time 5 to time 1 using the another rate which is given. Using the force of interest which is given between time 1 and 5, and then further e raised to minus 1 to 0, 0.04 ds. So this multiplied by this into dt. So this is how your integration looks like whenever the payment stream and three different rate of interest are given. And this is one of the most frequently occurring kind of a question that comes in the exam. So three force of interest or two force of interest along with one payment stream. So now if you can see this part of the integration and this part of the integration, these two factors are constants. It does not have t in it. So this can be taken outside and solved separately. Only this part into this part you have to solve yourself. So make sure that you solve this part, and this can be taken out as constant and solved manually differently, then multiply together. This is how you will get the answer for present value at time 0. And suppose now the question says find accumulated value at time 15. This is what the question asks if, for example. So the first part remains same from 5 to 10, 25 e raised to minus 0.02 t. This does not change. Now instead of the discount factor, we'll have to multiply accumulation factor. Now since the payment is starting from time 5, any interest rate which is given before time 5, that is from 0 to 1 and from 1 to 5 will become useless for you. You don't have to consider them at all. So here you have to do is e raised to integration. You have to accumulate all of them to time 15. So I know the upper limit should be 15 for sure. All of them to be accumulated to time 15. But from different time. The payment which is at time 5 is also to be accumulated to time 15. The payment which is at time 5.2 should also accumulate to time 15. Payment which is at time 5.8 should also accumulate to time 15. So in the lower limit I'll have a variable because we have to accumulate different payments between 5 to 10 to time 15. And then I'll use the given rate from t. For t greater than 5 I have a constant rate 24%. ds dt. This integral should give me the answer. So I'll leave for you to solve now, and I'll write such equation for one or two more cases, assuming that you know how to integrate functions. And the questions are displayed on the screen. You can look at the questions. What are the solutions are displayed on the screen. You can look at the solutions which is given and cross check whether the answer is right or wrong. And if you face any kind of difficulty, feel very free to get in touch with me. This kind of questions are really important, and assuming that you are looking at this for the first time, it may be quite tricky sometimes. So if you don't understand it in the first go, it is okay. Look at more questions. So before you solve this, I would recommend you to, I'm solving two more questions. So look at the way I'm framing the equations for these two questions. So first of all, you understand how to frame equations, and then you start solving it. So that it will be a little bit smooth. The only problem you may face is integrating, which is, I think you can manage yourself to integrate functions and then multiply them. That is not a big issue. So let us solve two more questions on this. So now this is the next question. The question again gives you three kind of force of interest. One is from time 0 to 6, other is from 6 to 8, and the third one is from 8 to infinity. The force of interest is the payment stream is given, and the payment is being made between time 10 and 15, and the payment stream is given as this equation. Now the question says find the present value at time 4. So let's see how the equation should look like. So present value is equal to, first integrating from time 10 to 15, because that is the time when the payment is being made. So being consistent with everything that we have done so far, the first limit of the integral should be the time when the payment is being actually made. Then 45 e raised to 0.01 t multiplied by the discount factors. So first, the highest time period here is 15. So instead of 15, we'll write t and the discounted to time 8. So that's how we did in the previous question as well. What this makes sure is every payment from time 15 to 10 is now discounted directly to time 8 using this factor. So the payment which is being made at time 15 will discount from time 15 to 8. Then payment at time say 14.5 will discount from 14.5 to 8. Payment at time 13 will discount from 13 to 8. So every payment will come down to time 8. Then from time 8 discount them back to time 6 using the force of interest applicable during that time period. So first discounting all the payments to time 8, then 8 to 6, and then from 6 to 4, not 0, because the question asks you to find present value time 4 and not 0. And the force of interest is given as 0.04 plus 0.005 s ds. The whole thing into dt. That is how the equation should look like. Now if the question says, let's say accumulate to time 20 for example, then it should be 10 to 15, 45 e raised to 0.01 t, then accumulate from, we know that we want to accumulate this to time 20. So upper limit should be 20 and the lower limit should be t. Now since this is starting from time 10, the payment is from 10 to 15, I want to accumulate to time 20. So everything that is related here is from time 10 to 20 only. There is nothing before time 10 that is applicable in this equation. So we'll use the only force of interest that is applicable after time 10, which is 0.04 ds. And anything before, which is before that, is not useful in this case. So this is how we would accumulate, and this is how we would discount them to time 4. So these are the equations. I hope you have understood the method that I am following to frame these equations, and you'll be able to solve this question yourself. So the last question for this chapter or this topic is this. So again we have 3 force of interest given, and the question says that payment is being made from time 10 to time 15 at the rate of 120 per annum continuously, and I have to find the present value of this payment at time 0. So here my payment stream is given 120 and the time for which it is applicable is 10 to 15. So present value is, first again the limit should be the payment of the payment is being made, that is from 10 to 15. Now we have 3 force of interest, so we'll have 3 discount factors in the integral. So first of all the payment is 120, that's a payment stream. Then e raised to minus integration, we have to first discount everything to time 10 starting from time t. Instead of the highest possible, we will use t always, and that should be 0.04 ds. Then from time 10, first we got everything to time 10, now from time 10 to time 6, because that's where the interest rate changes, 0.01 plus 0.003 t3s ds, and then from 6 to time 0, because that's where the question wants us to get the values at, which is 0.002 plus 0.01 t plus 0.0004 t square. Instead of t we should use s, ds and dt. So that's the equation for finding present value at time 0. Sometimes the question may ask you to find the equivalent effective rate of interest. Now what does that mean? The question have given you 3 force of interest and you use this equation. Let's say you get your answer as x rupees. So that is it in the chapter. So the chapter is over. We have supplied one assignment sheet with this video along with this video to you. So practice those sheet as much as you can. And if you have any doubt or queries, feel free to get in touch with us. And you can write us, you can WhatsApp us, you can do whatever you want to do to get connected and get your doubts cleared. If any of the question or any of the part of the videos unclear, please let us know. we can make another video for you, or we can explain it to you one to one, however it is convenient for both of us. So that's it for the day, for this video. Goodbye.